Hey POA students, just as a reminder, you're going to have a quiz tomorrow. It's going to be over the kind of stuff that is in this homework, so it's worth taking seriously. Make sure you're paying attention real close. Just as a reminder, when you're watching these videos, the best thing you can do is ask yourself constantly, do I understand why we did just that? Do I understand? Do I get it? Does it make logical sense? You can ask yourself those kinds of questions to try to help yourself think about it. This first set of problems kind of replays the card sorting activity that we did in class. So it says for each XY table in questions 1 through 4, find the graph and algebraic rule that show the same relationship. Okay, so let's go ahead and start with number 1. In class, we've talked a lot about finding the 0 row. And I'm going to start by highlighting that because that -1 that's next to 0 means that the rule has to have a -1 in it. So it's going to be something with an x minus 1 equals y. And so then I can think, well, how do I get from 1 to 1 if I'm subtracting 1? I'm going to make my pen a little bit thinner here and zoom in to do kind of like a mini process column here. Looks like that's as far as I can zoom in. Maybe I can do a little bit better with this. There you go. So we know there has to be a -1 in my rule because of that 0 rule. So then I have to think 2, or what -1 equals 1? It's got to be 2, and so I could do 2 times 1 minus 1. And so I'm going to try that on my next rule, or my next row, rather. So I'll do 2 times 2 minus 1. 2 times 2 minus 1 is 4 minus 1 equals 3, so it works. So I'm going to go ahead and zoom back out and see if this works in all of the rows. So 2 times 0 minus 1 definitely works. 2 times -1 is -2, minus 1 is -3. That works. So it looks like we're in good shape so far. 2 times -2 is -4. Positive times a negative is a negative. Minus 1 is more negative, and that does equal -5. So it looks like my rule is going to be 2x minus 1 equals y. So I'm going to go ahead and try to find that rule in the list of rules. Whoops. 2x minus 1 is right there. So I'm going to cross off j. I'm going to put j for my rule. Okay, so then I need to try to find a graph that matches it. And when I think about the graph, what I'm going to think about is its starting point, because that's where it crosses the y-axis. So I need to find one that starts at -1, and this one has a positive slope. If you don't know what slope is, that's okay, but it has a positive number next to the x, which means it should be increasing. But you can also see that the y's are going up by 2 each time. So I need to find something that goes through -1 and goes up by 2 each time. Let me just illustrate that a little bit. So if I'm looking at this part of the table, I can see that my y's are adding to every row. And so I should find something where the graph looks like it's increasing from left to right because y is increasing. Okay, so let's find one that crosses -1. Here's one that crosses -1. It crosses right there. And there's another one down here that crosses at -1 right there. So C and F are my potentials. So I'm going to look at how this one increases. This one seems to go up 2 over 1, up 2 over 1. I can also notice that it goes through the point, like right here, it goes through the point 3, 5. And in my table up above, if I were to add a row, I would get 3, 5. So C must be the correct one. So I'm going to go ahead and cross that one off now. And I'll erase my marks here. So we've got one set down. Okay, let's look at this next one. I'm going to change my colors here. So I'm going to look at the 0 row. And so that tells me that my rule must have +1 in it. I'm going to go to my positives here. Something plus 1 equals 0, and that would be -1. So I'll do -1 times 1 plus 1 equals 0. Let's try it for the next one. Negative 2 times 1 is negative 2 plus 1 equals negative 1. So it works there and there. I could also notice that this is taking away 1 each time. And so that gives me a hint as to what the multiplication is in my rule. So this negative 1 that is right here shows up in my rule as this negative 1 here. Now I just noticed that I made a mistake here. So this should be negative 1 times 2. Pardon me. Negative 1 times 2 is negative 2 plus 1 is still negative 1. So that still works. All right, so that gives me negative 1 times 0. Whoops, pardon me. Negative 1 times negative 1 is positive 1 plus 1 is 2. It's working. Negative 1 times negative 2 is positive 2 plus 1 is 3. Okay, so that's looking really nice. It looks like my rule must be negative 1 times x plus 1 equals y. And I know that negative 1 times x is just negative x plus 1 equals y, so I may need to look for that as well. So let's look at the rules. Negative x plus 1, it looks like it's the first one there. Negative x plus 1 is right there. So I'm going to go ahead and cross G off and mark it as my rule. And now let's look for a graph. And again, I'm looking for a graph that starts at or crosses the y-axis at positive 1. So this one crosses at positive 1. There it is right there. Let's see if there's any other candidates. Here's one that crosses at positive 1. So I've got D and A are my candidates right now. And so I noticed in the column over here that y was decreasing by 1 each time. And so that should tell me that it's a graph that's decreasing or going down, and D is the graph that's doing that. It moves down from left to right. So D is my graph here. I'm going to cross it off. I'll erase my mark here, and I'll mark this as graph D. Okay. Continuing right along here, let's look at this one. I go straight to my 0 row, and I'll change colors again. So I know because this is a negative 1, it must have a minus 1 in the rule. So I'm going to put a minus 1 next to 1 here. So I need something minus 1 gives me negative 0.5. So that's negative 0.5 is negative a half. If I'm taking away 1, I think I need to take that away from a positive half. 1 half minus 1 is negative 1 half. So that's going to be times 1. I could have also noticed that this is adding 0.5 each time. And since it's adding 0.5 each time, and the 0.5 is the same as 1 half, that tells me that my multiplication is going to be 1 half. So I'll go ahead and try that with 1 half times 2. 1 half times 2, a half of 2 is 1, minus 1 is 0. Cool. 1 half times 0 minus 1 is negative 1. 1 half times negative 1. 1 half times negative 1 is negative a half. Minus 1 is negative 1.5. Cool. 1 half times negative 2 is negative 1. Minus 1 is negative 2. All right. So my rule must be 1 half x minus 1 equals y. 1 half x minus 1 equals y. So let's see if there's any rules that kind of look like that. Well, there it is. It's the second one. 1 half x minus 1 is right there. Not having to look too hard for it. So there's h. So now we need to find a graph that crosses at negative 1 and is increasing by a half each time. So let's look for the ones that are crossing at negative 1. Here's one that crosses at negative 1. So that's one candidate. Where's another? Do we have any other candidates? Yeah, here's one. Negative 1 crosses right there. Okay, so which one of those is increasing, B or F? Well, B goes down from left to right, and F goes up from left to right. So it's got to be F. So I'll go ahead and cross off F, I'm going to put F for my graph right here, and we are on our way. Okay, all right, going straight to the 0 row once again. So that tells me I have a +1. I'll change colors again just to color code all this stuff. I've got +1 in my rule, so I'll go to my next row, +1. I'm going to go ahead and see how it's changing here. So this one is +2, +2, +2, +2, because 3 + 5 is 2. So that tells me my multiplication must be 2 times 0. I'll zoom in here. 2 times 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times -1 is -2, plus 1 is -1. 2 times -2 is -4, plus 1 is -3. So we are in excellent shape here. I am looking at a rule that is 2 times x plus 1 equals y. So let's see if that's on our list over here. Well, this one is 1/2, so that's not it. And -x, that's not it. 2x plus 1, there it is. So L is the correct thing for my rule. And now we need to find something that, again, is going to start at 1, and it should be increasing. So let's find something that starts at 1. Well, here's one that starts at 1, and it is increasing. So I think A is a strong candidate. Are there any others that we haven't chosen that start at 1? It does not look like it. And so A is the guy for green here. Okay. Awesome. So we have found every rule and every graph. Let's go ahead and move on. Fill in the missing representations. I'll let you know that there is a test question on this unit test that is exactly like this. So it's worth taking this part really seriously. You might want to try it on your own and then come back and see if you work along with me if you get the same thing. I'm going to go ahead and start with the graph. I'm noticing in my x's and y's that I have both positives and negatives in both of them. The biggest x value is 0. Whoops, sorry. The biggest x value is 4. And the biggest y value is 29. The smallest x value is -3, and the biggest x, or smallest y value is -10. So I need to go -10 to 30 in the y's. So I'll go ahead and draw in my axes in blue. And I'm looking at this, and because I'm a math teacher, I'm noticing this is a little funny right here. This should actually be 10, not 0. So that'll help us out here in just a sec. So I actually need to get to 10, not 4. Okay. I'm choosing to put my axes around here for the reason that I have to do more positive stuff than negatives. So 29 is bigger than, or farther away from 0 than -10, and 10 is farther away from 0 than -3, so I don't need as much room. So I'm going to go ahead and label, and I'll label in a different color. My x's, I think I can just count by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got up to where we needed to with a little room to spare. 11, 12, and then -1, -2, -3, -4. So that looks good. And 0 is where they cross. I need to get down to -10. I think I'm going to count by 2s and see how that goes. So -2, -4, -6, -8, -10. So that worked out kind of nicely. And then -12. And then all the way up to 30. So 2, 4, 6, 8, 10, 12, 14. I'm not going to get there. 16, 18, 20. So I do need to adjust that scale. so this is the guess and check method. Sometimes we make mistakes, and that's okay. Oops, I erased my axis. I'll just leave that mark there. Okay, let's try counting by threes. So -3, -6, -9, -12, -15, -18. So that looks okay so far. And that would be 3, 6, 9, 12, 15, 18, 21, 24, 27, and there's 30. Okay, so we are in pretty good shape now to start graphing. Okay, so let's go ahead and plot the points. I'll plot the points let's do this green color, why not? And I'll make my dots about that big. So -3, -10, so I'm going to go left to -3 from the origin on the x-axis, and then I'm going to go down to -10. -10 is 1 past -9, so it's going to be right about there. Okay, -1, -4, so left -1, and then down, and then -4 is 1 past -3, so it's right about here. Okay, 0, -1, that's no left or right movement, then down 1 from 0. Okay, 1, 2, so I go to the right 1 and then up 2, that's 1 less than 3, so it's going to be about there. 2, 5, so I go to the right 2 from the origin and up 5, right underneath 6. 4, 11, over 4, and then up 11, 1 less than 12. That's a little off. It looks like a nice line so far. And then 10, 29, so I go to the right 10 and then up 29, that's 1 less than 30, right there. Okay, so I've got my graph made. It's feeling pretty good so far. Let's go ahead and write the rule. So I know that it must have a minus, whoops, that's a pretty thick pen. I know it has to have a -1 in it because of that row. I notice that when x is going up +1, y is going up +3. So that's 3 times x minus 1 equals y. So 3 times 30, or 3 times 10 is 30, minus 1 is 29. 3 times 4 is 12, minus 1 is 11. 3 times 2 is 6, minus 1 is 5. So that sure seems like the rule. So that's 3x minus 1 equals y. All right, -10x plus 20. -10x plus 20. So my x is, let's make a totally positive graph because there's nothing saying I have to use all 4 quadrants. 4, 5, 6. -10 times 0 is 0, plus 20 is 20. -10 times 1 is -10, plus 20 is 10. So this is interesting. I noticed that this has a -10 in it, and this went down 10. So I think the pattern is going to be that this goes down 10 again. So let's just double check. -10 times 2 is -20, plus 20 is 0. So my pattern seems to work. This is going to take away 10 each time. And I'll just double check with 6. -10 times 6 is -60, plus 20 is -40. Okay, make my pen a little thinner here. So I have 0 to 6 on my x-axis. Oh, I need to do a better job of this. My x-axis needs to be somewhere close to here. X. And that's because my y's go from -40 all the way up to +20. So my x-axis goes there, my y-axis is going to go here. Let's make every 3 lines equal to 1 on the x-axis. And see if that works. 4, 5, oh, not quite. Every 2 lines will be 1. 3, 4, 5, 6, 7. Okay, and then let's count by 5. So every 2 lines will be 10, 20. I'm just guessing here. -10, -20, -30, -40, and that worked. My guess was right. And my guess there was I wanted to count by something that would allow me to graph quickly, so I made my lines equivalent to what the y's count by in my information. So 0, 20 is right there. 1, 10, right 1 up 10. 2, 0 over 2, up and down 0. 3, -10 is to the right 3, then down 10. 4, -20 is to the right 4, and then down 20. And then 5, -30 over 5, down 30. And I'm just going to guess the next one goes right here because there's a nice pattern. All right, looking pretty good. I think we have 1 to go here, and then I'm going to have to take a break and I'll come back to it. All right, so let's go ahead and analyze. Whoops, I forgot to write a rule up here, didn't I? No, the rule was given. Whoops, sorry. Okay, so let's try to parse out some points because we need points to be able to fill out a table. I like to look for what are called lattice points, and that's where the graph clearly crosses at the hash marks. As many of those places as possible is great. So I see it does cross at 0, 0. I'll make my pen slightly smaller because that's obnoxiously big. So 0, 0 is a spot where it crosses. It sure looks like it crosses near 15, but not quite. So we'll have to do a little bit of estimation here. It looks like 1040 is definitely a spot. And 520 crosses the axis nicely there. So it crosses an up and down hash mark and a side-to-side hash mark. -520 and -1040 works as well. So I'm going to go ahead and fill this out. With those 4, I'm going to go ahead and put 0, 0 in the middle. And then I'll put 520 and 1040, -5, -20, -10, -40. I'll make my pen skinnier since my handwriting is so good. -5, -20. So I'm noticing this pattern here. It's jumping up by 20s. So I think if I continue that pattern, I'll end up here. That is 60. And this is jumping up by 5s. So that would be 15. That would make this -15 and -60. Just using the patterns in my table. All right, so now we need to figure out how to write a rule for that. I know there's no addition in the rule because it goes from 0 to 0. So it's just going to be multiplication. So I need to figure out what do I multiply x by to get y. I'm going to look at the positives. 5 times something is 20. 5 times 4 is 20. 10 times 4 is 40. 15 times 4 is 60. So that sure seems like it's working. My rule must be 4 times x equals y. All right, I'll come back and do the staying sharp here in just a little bit. All right, and we're back. Okay, Venu goes to a fruit stand and buys some apples and bananas. Let A represent the number of apples she buys, and B represent the number of bananas she buys. CA is the cost of each apple. CB is the cost of each banana. Is the expression A plus B meaningful in this situation? If so, what does it mean? If not, why not? Well, A is, I'm just going to do the first level translation. This is one strategy for these kind of problems. A is number of apples plus, make my pen a little thinner here, number of bananas. And if you add those two together, I just know that like what you're looking at is a basket of fruit. And so that is the total number of pieces of fruit. Pieces of fruit. All right. Expression A times CB meaningful in this situation? If so, what does it mean? If not, why not? All right, A times CB. So that's number of apples times cost of bananas. Number of apples times cost of bananas doesn't make sense. So I know that when you take a cost times a number, you find a total, but you have to take the cost of the thing. So if you went to the register with this, you'd be upset because if they charge more for bananas than they do for apples, you'd be getting overcharged because you don't. This says charge me the amount for bananas for each one of my apples. That doesn't make sense. So it doesn't make sense because you have to multiply costs of the same object. It's kind of a really clunky way of putting that, but basically you have to, if you're going to find the total cost of something, you have to do the work to make sure you're multiplying the cost of the right thing times the number of something. All right, write an expression for the total cost of Vindu's purchase. So I know that it's going to be the cost of the apples times the number of apples, and that's going to be total cost of apples. And I apologize for my handwriting. My stylus is getting a little worn out here. CA times A, and then I'm going to add to that CB times B because that's the total cost of bananas. So if you take the cost of an item, multiply it by the number of that item, you always get the total cost, and so that's the total cost altogether. Cool. All right, Kevin works in an internet cafe. The cafe charges customers based on the amount of time they use the internet. There's a flat fee of $3 for all users. In addition, users are charged 20 cents for each 10-minute period they use the internet. Which of these two statements makes more sense? The amount of money charged depends on the amount of time spent on the internet. The amount of time spent on the internet depends on the amount of money charged. I'm going to say A. They measure your time and then give you a bill. That's what it means to depend. That means the bill depends on the time. Customer at the cafe is charged $4.60 for her time on the internet. How many hours was she on the internet? Show your work. All right, so $4.60. So there's a flat fee and then 20 cents for each 10-minute period. Okay, so I know that if I start with 460, I'm going to write it a little bit smaller so I have room here. $4.60, I'm going to take away the $3 fee, and that's going to give me $1.60 that's charged at 20 cents an hour? Yeah. For 10 minutes. Okay, so then I'm going to take 160. If you take the total charge and you divide it by the rate, that's 0.20, you'll get the amount of time. So that's 1.6 divided by 0.2, which is 8. And so that is 8 10-minute sessions, or 10-minute chunks, we'll put. So From there, I need to answer a number of hours. So 8 10-minute chunks is 80 minutes. To find out the number of hours, I'm going to do some unit analysis. I'm going to multiply this by 60 minutes for 1 hour. So minutes and minutes cancel out, and so I'll have 80 divided by 60, because 80 times 1 multiplying across is 80, and then 1 times 60 multiplying across is 60. So that's going to give me 1.3 hours. Cool. This graph illustrates the total number of students accepted to college from Miss Fredrickson's class. Estimate the value for February. So something I notice is that this appears to be kind of having a pattern. So all the dots kind of fall in that highlighted area. So my estimation should probably fall in there too. And that tells me that it's about 7. Assume the pattern continues and estimate the value for November. Okay, so I'm going to just continue my highlighted bar there. And November, I'm going to go up to where it would be. And so it looks like it's probably going to be around 26. In which value you're more confident? Why? I think I'm more confident about February because it is in the past and fits the past pattern. And you can only be somewhat sure that the pattern will hold in the future. So you can make better, you can use past data to make better assumptions about what happened in the past than you can use past data to predict about the future. That's just a general thing. So let's say that you traveled and you went on a trip and you came home. Now, you did not see the sunrise in the place in your home while you were gone. So like if you traveled to Florida last weekend, over the weekend, you did not see the sunrise in Columbia. But you can be reasonably sure that the sun rose in Columbia. Now, we don't know what will happen in the future, and something crazy might occur such that the sun does not rise in the future, even though that's super unlikely. But we can be less sure that the sun will rise 1,000 years from now on Columbia. Then we can be sure that it rose over the last weekend, because Columbia was here before and also after, and the sun rose on every day before, and it rose on every day since last weekend. Anyways, that's kind of a long-winded explanation as to why you can make good predictions about what happened in the past, but have a little bit less confidence about using patterns to predict about the future. All right, see you guys tomorrow.